Greetings, chem students. This is Mr. Braun, and today we're going to discuss density of an unknown metal and accuracy and precision in measurements. The objectives of this lab are to calculate the values from experimental measurements, organize data in a reliable manner by compiling it in tables, calculate an average value from class data, and use it to calculate absolute deviation and average deviation, recognize the importance of accuracy and precision in scientific measurements and the difference between them, use the property of density to help identify materials, and finally, understand deviation, uncertainty, and percentage of error. Now, what we are going to do, you're going to need these equations. We should know that density is equal to mass divided by volume. You're going to need to be able to calculate the volume of a cylinder. Experimental error, which is also called absolute error. Okay, this is the observed value minus the accepted value. Percentage error, which is the absolute error you have right here, divided by the accepted value multiplied by 100. Now these two equations here, you will be using these throughout the entire year. So it's important to know where this density of an unknown metal lab is in your binder so that you can refer to them later on in the year. Okay, safety measures that we need to take. Okay, before beginning each part of this experiment, take the necessary safety precautions. Wear safety goggles. Now, it is always a good idea to get into good habits, okay? Good habits include using the proper safety equipment, such as your safety goggles. All right, so make sure that you have your goggles on for this lab. Now, the apparatuses that you are going to need are as follows. Now, one thing we're going to talk about here a little bit later, it says 25 and 10 milliliter. I believe the pennies will not fit into the 25. We're going to have to use the 100 milliliter for that one also. Okay, although it says the 25, we're going to use the 100 because the pennies won't fit. Okay, now the first part of the procedure, okay, you're going to read through this and you're going to use a plastic ruler. Okay, if it's not a plastic, it could be a wood ruler, doesn't matter. So you're going to use a ruler, you're going to make some measurements and follow the directions, okay? Make the measurements, calculate and determine what the uncertainty is of the ruler, uncertainty of the balance, etc., etc. Part 2, okay, part 2 is this is where it says to use a 25 milliliter graduated cylinder. The pennies will not fit into your 25 milliliter graduated cylinder, so make sure that you use the 100 milliliter graduated cylinder, all right? So what you're going to do is you're going to go through, use water displacement to calculate the the volume of 10 pennies, okay? You're going to use the volume of 10 pennies to calculate the volume that would be of a single penny. After you have that, you're going to get a gold penny. A gold penny. You'll have to come up to me and say, Mr. Braun, can I please have a gold penny? And I say, absolutely. Here you go. Now, I'm not going to lie to you, folks. This penny looks gold, but it's not actually gold. All right, it's not actually gold. If it were gold, I'd have it put away somewhere else because gold's pretty valuable. All right, so you're going to do your mass, your gold penny, do all that with your gold penny. Once you're finished with it, you should bring it back to me so that I can have the gold penny back. All right, clean up your lab area and then start working on the calculations. Here's a data table for part 1, which is dealing with the balance and the ruler. Here's a data table part 2, which is dealing with the water displacement and the gold pennies, okay? And then you're going to use that to do the calculations. Now, here is one calculation. A lot of people throughout the different times of doing this lab think that they don't have to do anything for this one right here. That is not the case, because this is an example. Your measurements will be different. Okay, I don't expect you to have this being the radius, and I don't expect you to have this being the centimeters. Okay, so you need to make sure you use your value. So don't mistakenly think you don't have to do anything for here. All right. Now here's where you're going to calculate the absolute and percent air, and the accepted value for the graduated cylinder should be 50 centimeters cubed. Now, if you look, here is centimeters cubed. Okay. One thing we need to be certain of is we need to know that 1 cubic centimeter, 1 centimeter cubed, is equal to 1 milliliter. So 1 cubic centimeter equals 1 milliliter. You might hear sometimes, if you watch a movie or some kind of TV show dealing with a hospital, they talk about cc's. Those are cubic centimeters. Okay, give me 50 cc's. All right, you might hear a doctor say. Okay, that's a cubic centimeter, which is the same as 1 milliliter. All right, down here you're going to calculate the density of the gold coin, and then you're going to use the periodic table. Okay, you're going to get the accepted value for your gold penny as the density off of your periodic table. I gave you 2 different periodic tables. They're the same. Just get the density of the gold penny from that periodic table. After you've done those 4 calculations, you need to answer the questions that we have here. Okay? So this part has 3. Explain, give proof, has 3 different ones right here that you will be calculating. So answer the questions, and then that's the lab. This has been Mr. Braun talking about the pre-lab video for density of an unknown metal and accuracy and precisions in measurements. Chem students, let's investigate.